All right, let's start by reminding ourselves of the trigonometric ratios of sine, cosine, and tangent, because we're going to be applying those today. So remember that the first thing you want to do when you have a right triangle is identify the hypotenuse, because when we talk about the opposite leg and adjacent leg, they are not the hypotenuse. The hypotenuse is always the longest, that longest diagonal side, and it's across from the right angle. So that's what I like to do, is identify where is my hypotenuse first, so that I don't accidentally use it as either my adjacent or my opposite. The next thing, let's find for angle M here, the sine of M. Okay, so here's angle M. Mark my angle, this corner here. It says sine is the leg opposite over the hypotenuse. So when we say the leg opposite, we want the one across the figure from angle M. So opposite angle M is length 3 over the hypotenuse, which we marked is 5. Okay, let's say I'm finding the cosine of M. Cosine is the adjacent leg over the hypotenuse. Okay, so again, we're at angle M. Adjacent leg means the leg right next to or touching it. That would be length 4. And then over the hypotenuse, again, my hypotenuse was 5. And finally, the tangent of M. Okay, tangent of angle is the opposite leg over the adjacent leg. So we start again. Here's our angle. The leg opposite or across the figure from it is length 3. The leg adjacent to it is length 4. Notice the hypotenuse is not involved at all in the tangent. Okay, let's do the same now, but let's work with angle L this time. Okay, so let's find the sine of L. So now you want to make sure, okay, what angle am I working with? I'm working with angle L, so we're working from this corner this time. Sine again is the opposite leg over the hypotenuse. So the leg opposite of L, the one across the figure from L, is 4. Over the hypotenuse is still 5. Let's find the cosine of L. Okay, so here's our angle L. We want adjacent is what it says to do for cosine. So the leg touching angle L was length 3 over the hypotenuse of 5. And finally, the tangent of L. The tangent is the opposite leg over the adjacent leg. So here again, here's our angle. The leg opposite or across the figure from it was length 4. The leg adjacent or the leg touching was 3. So we have 4, our opposite, over our adjacent 3. And notice they're inverses of one another, the numbers for M and the numbers for L, which is why it's so important to make sure you're working with the correct angle. Okay, so that is just a real brief review of what sine, cosine, and tangent ratios are. You want to make sure that you are using them properly. This question says the sine of A is 4/5. Determine which of these angles in the triangle is angle A. Is it angle 1 or angle 2? So what we're going to do is, let's see, okay, if the sine of A, if the ratio is 4/5, if it's reduced and simplified, what fraction or what decimal is that? So I just go 4 divided by 5. Okay, is 0.8. Okay, so then what we're going to do is find the sine of angle 1 and the sine of angle 2 and see which of those have a sine equal to 0.8, and whichever that one that is, that's our angle A. Okay, so let's set up what would be the sine of angle 1. Okay, so where is angle 1? Here it is. Right, where is my hypotenuse for the triangle? Across from the right angle here, here's the hypotenuse. Okay, so for angle 1, sine again is opposite over hypotenuse. So the leg opposite angle 1 is 4.8. The leg, and then over hypotenuse, the hypotenuse is 6. Okay, so the sine of angle 1 is 4.8 over 6. Just go ahead and divide that. Do top divided by bottom. 4.8 divided by 6 is 0.8. Okay, well, notice that's what we're looking for. We want to know which of these two angles had a sine of 0.8. So I'm going to say, right off, I can say angle 1 is my angle A that I was looking for. Let's see what would have happened. Had we used angle 2, how would we know angle 2 was not the answer? So I know my answer is angle 1, but let's just keep going just in case you try the wrong angle the first time. So we would do the same for angle 2. We would find its sine. So we do opposite. The leg opposite angle 2 is 3.6 over hypotenuse. Our hypotenuse was 6. We divide. 3.6 divided by 6 is 0.6. So the sine of angle 2 was 0.6 and not 0.8, which is what we were looking for. So we would have known it was not angle 2, and it is angle 1. Again, so what I did is I used the figure to find the sine of angle 1. It was 0.8, and then I found the decimal for this sine. It was 0.8. Okay, so A would be angle 1. Let's try another one. Use the fact that the sine of B is 15/17 to determine which angle in this triangle is angle B. Is it angle 1 or angle 2? So again, the first thing I'm going to do, because it's harder to compare them in fractions, is I'm going to change 5/17 to a decimal. And again, to do that, you take the top divided by the bottom. So 15 divided by 17 is 0.88235, and it keeps going from there. Okay, so whatever angle B is, its sine is equal to 0.823. Okay, now we're going to find the sine of angle 1 and the sine of angle 2 and see which of those is also 0.88235. So where in my figure is my hypotenuse, just so I don't use it as one of my legs? Again, it's always across from the right angle. So here's the hypotenuse. Sine is opposite over hypotenuse. So for angle 1, here's our angle 1. We want the leg opposite. What leg is opposite angle 1? The 27 over the hypotenuse of 30.6. I'm going to find the decimal number for that. So I take the top 27 divided by the bottom 30.6, and I get 0.88235. Okay, well, there's my answer. Angle 1 is the angle B for this figure. Again, I'm just going to do angle 2 just for practice, okay? So let's find the sine of 2 and see how we would have known it was not angle 2 for sure. Here's angle 2. Its sine is opposite, so the leg across from angle 2 was 14.4 over the hypotenuse, which was 30.6. We divide. 14.4 divided by 30.6 is 0.47. So the sine of this angle was 0.47 and not 0.8, which is what we were looking for. So we would have known it's not angle 2. It was, however, angle 1 was our angle B. They had the same sine.